Okay, welcome back to math class and welcome to chapter 10. Up until this point, we've talked about linear functions, we've talked about quadratic functions, cubic functions, absolute value functions, exponential functions. Today, we're going to talk about square root functions. So basically, a function where y equals the square root of x. Now we call these a radical function because if you remember when we learned about square roots, this symbol right here is called a radical. So the whole thing we call a radical function. The whole thing is a radical function. The thing that's underneath the radical in the expression, we call the radicand. That's whatever's underneath the radical is the radicand. Now, square root functions, always, when you graph them, they're going to look like this. That's our form, just like how linear functions form a line, quadratic functions form a parabola, you know all of that stuff. Square root functions look like this. Now what we're going to be doing today is graphing some of them using a table just like we have in the past. So let's go ahead and try graphing this. Y equals the square root of x. So I'm going to make my table. X, y equals the square root of x and y. All right. Now, the interesting thing about square root functions, because we know that you can't have a negative under the square root symbol and it be a real number, these values don't ever go, we won't ever get a negative x value here. At least not as long as it's a plain value like this. See, it starts at 0 and it goes that way. So our domain, our x values are all the numbers greater than 0, greater than or equal to 0. So our x can be 0, but it can't be -1, -2, -3. It has to be, so we're going to go 1, 2, 3, 4. I say all that to say normally we do -2, -1, 0, 1, 2, so that we see some of our graph on the left-hand side of the y-axis and some of it on the right-hand side. But with square root functions, we're going to go 0, 1, 2, 3, 4 because we won't have any on the left-hand side. All right, so let's plug it in. Y equals the square root of 0. The square root of 0 is 0. Y equals the square root of 1. The square root of 1 is 1. Y equals the square root of 2. The square root of 2. Now, when you get to these that aren't perfect squares, it's okay to use your calculator. So when we put the square root of 2 into our calculator, we're going to get approximately 1.4. And we're going to do y equals the square root of 3. Square root of 3 is going to be approximately 1.7. Let me go ahead and finish off our table. Now 4, y equals the square root of 4. You guys should know that one. The square root of 4 is 2. Okay, so we have our x values and our y values. Let's graph it. I'm going to use this graph I made earlier. Okay, so I know that my x values, I'm going to need them to go from 1 to 4, and my y values to go from 0 to 2. So I'm actually going to extend this a little bit. Because I want to go all the way 1, 2, 3, 4. So then we need 1, 2. Okay, so when my x is 0, my y is 0. So I'm going to put my first dot at 0, 0. When x is 1, y is 1. When x is 2, y is 1.4. So I'm going to look. 1.5 is halfway between 1 and 2, right? So I'm going to put my 1.4 dot a little bit below 1.5. When x is 3, y is 1.7. So I'm going to put that one just above my 1.5 dot. And then when it's 4, it's going to be at 2. So I connect my dots, and it looks like that. And it's in that same form, so we have a pretty good idea that we did it right. Hopefully that makes sense. Now, just like when we did quadratics and we practiced all the different ways that adding something to this equation changes the graph, we're going to look at what that means with radical functions as well, square root functions. First things first, we have our base function y equals the square root of x, and it looks like that. If I take a negative number on the outside, here I just put a negative sign, so that would be -1, but if it was -3, -4, -1/2, whatever on the outside, but it's negative, it's going to do the same thing as happened with our quadratics. It's going to move, it's going to flip our graph upside down. So if I have a negative here, our graph, instead of looking like that, like it did before, it's going to come down like this. See, so positive over there, negative over here. That's if we have a negative in front. If, again, starting from square root of x, if instead of multiplying by something, I just add a k to the outside, any number, the k just stands for any number. What I'm doing there is I'm telling you how many spaces to move up or down along the y-axis. So an equation that was square root of x plus k is going to look like this. You see how it doesn't start at 0, 0 like this one? It's moved, since I said plus k, it's moved up along the y-axis, however many spaces k is. Whatever k's value is, that's how many we move up or down the y-axis. One last thing, y equals square root of x plus h. So if we're adding something underneath the radical, that's going to tell me how many spaces to move my graph left or right. So for this one, I've said plus h, so instead of starting at 0, 0 in the middle, I'm going to start right however many spaces h is. Hopefully this makes sense because it's really similar to what we did with quadratics. Negative sign, upside down. Add a k on the outside of the radical, moves it up and down. Add an h on the inside of the radical, moves it left to right. You guys got this.